Okay, so I guess we'll start now. Hello, everyone that's on the meeting. My name is Ismail. I'm a software developer here at AWS Labs, and this is going to be the second Zoom meetup that we're going to host today. And we're going to have an interactive meetup where we're going to start with a first part of a much larger serverless series. Today's topic is going to be building AWS Lambda projects for production. And in the first part of this workshop, we're going to have Visar to talk about the theoretical part of the topic, to give us an overview of DevOps and AWS services in general. And then in the second part of the meetup, Shvetim is going to take over and demonstrate how we organize our code around Lambdas here at Polymath Labs. And the agenda will be, as it was described in the meetup link. We're going to have an introduction and overview of our topic. We will have live coding and interactive session, and then at the end, we'll have Q&A. So again, thank you everyone for participating in this event. The event will be held in English, since we have some international guests. We have Darko here, who is an AWS. Darko, can you hear us?
Yes, I can. Hi.
Hey, thank you for being with us today.
Happy to be here again.
And also we have Zamira. I see that she joined as well.
Hi guys, happy to be here and nice to meet you all.
Thank you. Okay, so Darko is an AWS evangelist. He was holding the second meetup here with us in Pristina, where he explained and talked about one of AWS conferences and the news about AWS in general. So without further ado, I will leave to Visar to start the workshop.
Thank you, Ismail. Welcome, everyone. Welcome to this meetup. We're working under unusual circumstances, as you all know. Hopefully everyone's safe and healthy. We're doing our best to keep the community alive, and hopefully we'll get some good participation going today. The good news for the delay that we had due to the link mishap is that the session is being recorded, so it'll be available to those that could not attend or couldn't join on time. The topic itself is a continuation of the conversations that we've been having around development in the cloud. And so what I'm going to cover today, I'm not going to spend too much time because the second part of this session is more interesting. But what I wanted to do is just cover a little bit of logistics of how this is going to be executed, considering there's a hands-on portion of it. An overview of what the topic is, and then we'll switch over to demo and we'll do Q&A at the end. It's going to be a hands-on lab, so the idea is that you're going to learn by doing. If you are able to, it would be great. You can follow Shvetim as he's going through the exercises. He's going to share resources to get you started, so you're not starting from scratch. But the best way to learn is by doing. So if you can, please follow. You obviously need an AWS account. If you don't have one, maybe you can try and get one while I'm covering this presentation and be ready for the demo part. And then the required software, it's actually fairly lightweight. You're going to need Git, some kind of editor, the serverless CLI. Again, all of this will be covered in the hands-on portion. I just kind of hoped I would give you an opportunity to catch up beforehand so that you can be ready when the hands-on demo starts. And then have fun, participate, have fun, ask questions. We'll do our best to cover questions, but I'm sure some of the questions that you may have are going to be a little bit beyond the scope of the session, and we can take those offline. All right, so let's talk a little bit about the how we got here, the previous sessions. Last November, our first meetup, we talked about cloud native architectures, and we did a hands-on serverless demo. Some of you may have been there. This was an in-person meeting. The second relevant to this topic session that we had was the last webinar we did, which was the introduction to DevOps. And what we covered there was principles of DevOps, but also we had some practical guides and tools and things of that nature. Today, the session is around building AWS Lambda projects and building production ready. So we're not talking about building a hello world application, but we're talking about things that you can do to build a production ready Lambda project. And so the sample application that we're going to build is going to be a web application based on a serverless backend. Just to recap to those that have not attended the previous sessions and may not be familiar with the terminology. So what are we talking about cloud native? In a legacy environment, data center type environment, what you have is you have an organization owns the entire technology stack of their infrastructure. So starting from hardware, virtualization, operating system, all the way to the application logic. Cloud natives flips this completely aside, and what you want to do is, if you're a startup or any kind of organization that doesn't need to own those tiers below it, you only want to focus on the application logic. And so the idea of cloud native is that you're developing solutions that minimize the ownership of the technology stack. And in this case, the outsourcing is being done obviously to AWS. When it comes to serverless, when we talked about this at the previous meetup, we said that serverless is the most significant innovation in the cloud since the cloud itself. This was a bold statement we believed in then, and it's a bold statement we believe in today. Why? Here are some of the reasons. No server management or provisioning. We have implicit auto-scaling. Most organizations that move to the cloud, they talk about auto-scaling and other capabilities that the cloud has to offer. But when you're talking about auto-scaling, you're simply talking about the ability to auto-generate new resources on demand. And those resources still have to be configured. They have to be owned, provisioned, and paid for by the hour. When it comes to serverless, you have none of this burden on your organization. You pay by the second, and only during the time while your code is executing. So there's no overhead, no infrastructure running while you and your users are sleeping. Rapid development tools, you get very fast time to market, which we're gonna explain today. You'll see it in action. And then it's an ideal match for microservice architectures because of the nature of serverless, as well as the complementary services that are available by AWS, such as API Gateway, Cognito, and DynamoDB. Cognito is obviously not serverless, but it's a very complementary technology that enables serverless. Okay, so what's the hands-on lab today going to cover? It's going to be a React serverless application. So the front end is going to be a single page React application with a serverless backend. It's going to include enterprise-ready continuous integration and deployment infrastructure, both infrastructure as code as well as the deployment automation pieces. And then we're going to have a serverless and managed service backend. So the managed service component is a MongoDB compatible database, which is the DocumentDB managed service offered by AWS. Now, keep in mind that when we talk about a production-ready application, we actually mean that. So this application, the way it's being developed, can be deployed to production. But that also means that there's a lot that we're not going to cover today. So today is actually part one of a series of these hands-on labs that we're going to do to help you understand the capabilities of AWS in the serverless space. And without further ado, let's switch over to Shpatim and to the hands-on portion of this session.
Hi guys, thanks for joining today. As Vishar already introduced me, I will be your hands-on guy. We will be covering fully managed continuous integration on AWS for both front-end and back-end, and also resources on AWS. I want to first talk about what we mean with production ready, as Vishar told.
Shpatim, I apologize. Let me just interject really quick. Darko was generous enough to offer us some AWS credits. So what we're going to do is for either if you have questions and someone answers, or if we get some good questions, we're going to be giving these points away. So I'll keep track, and then I'll send you the codes at the end of the meeting. So please participate. Whether you're answering questions or asking the questions, we have some credits for you.
Cool. I'm gonna share my screen and try to do descriptive what production ready and what is easy to do in AWS. The cloud in overall is designed to be ready in seconds, to be live in seconds. It is advertised as it, and it's really easy to do that. In AWS, we have Lambda, and you can easily create a function, follow this instruction, and you will have your first computing cloud ready for you. But this is not production ready. You can't be managing a whole microservice production ready application by going through console and creating and linking. Deployed, you need database, you need API gateway, you need to link these with each other, and that it's not easily done in console. So we open sourced today a project that does it for you, a full automated deployment for DocumentDB, React, and Node. It can be found under Polymath Labs GitHub account, and we will use this to deploy a project and also deploy some custom CRUD REST APIs, and also do some changes to components in React. And all of these must be fully automated, no need for DevOps involved to spin up new environment or do deployment for us. So before this call, I already forked on my personal account this repository, and I installed Node modules because I have bad internet connection. So if you are following me, please fork this repository and install Node modules in API, in apps, and web. We will continue from there. There are some requirements. For example, you need to have your AWS account already configured. You may have also that point. there is one manual thing that needs to be done, and that's secrets creation. Reason behind it is secrets are usually sensitive information. It's not supposed to be to leave trace in code. So for these, we will need to create manually. In AWS, we have secret manager, which holds secrets for us, and usually it's accessible from all other resources. In our case, we will access it from CloudFormation. I've already created a secret. How you have we'll be using all type of secret. We will simply providing some basic information, nothing related to other services. Based on README I've provided, we will be creating these keys where source repo owner is going to be your own account in GitHub, is going to be your username. In my case, it's going to be my name and last name. Is going to be a repository name, which you already, I believe. So in my case, it will be this one.
Could go a little bit slower and maybe explain, repeat things.
All right. So basically, what we need to do in first step is to create these secrets, provide this information that we will be using during deployments. These are sensitive information. For example, we will be providing DocumentDB username and password that CloudFormation will use to create an instance of DocumentDB and set this username and password as master account. Then you go to developer settings, and personal access tokens can be generated here. All you need is repo, full control of private repositories for this exercise. So if you generate a new token here, you will receive a string that you will set here. I've already done that, so I'm gonna fill this information with dummy data just to pass this screen. It's important because we will need this secret name to set an environment variable for starting a new deployment. This is how CloudFormation can find the secrets and apply them. So whatever you name them, automation deployment, for example. Just make sure you copy it because we will be using it. Right, so there is no other needs to configure secrets. That's it. You will be moved to a review page, store. That's it. Now this name needs to go in code. By code, I've already gave that information a little bit. And give this information. First name will be the name of the project, will be our stage is going to be deployment stage. For now, we can leave it dev, and then we can also deploy a new environment, for example, QA or demo. And AWS secret name is the name that we left to the AWS secrets that we need to apply. Also region, if you have an account and you want to apply this infrastructure to a specific AWS region, you need to also specify the region. Stage will be fallback to dev. If not provided on my local machine under the other end, and it looks. I named project Hello World, and I gave AWS secret name here. I'm gonna deploy on US East 2 with stage of dev. Now, if we go through my account in AWS, for example, if I go to Lambda, where functions will be deployed, I have nothing. I have only one left function here. If I go to pipeline, whoever have experience with DevOps, code build and code pipeline helps us to create the infrastructure, which we will go through and cover what is going to be deployed after I start, because this will take some time. Usually, as I said in the first place, it's easy to go live in cloud within seconds, but not for production. If you set, for example, Lambdas, if you set VPC, some subnets, and security groups, it will take longer to deploy. So for production, usually this kind of deployments takes more time. If you already have installed serverless, or if you just did npm install here, this repository have as dependencies serverless, .env, and other libraries that we need. You won't need to have serverless globally installed. Otherwise, in other projects, usually these packages are under dev dependencies and not in dependencies. But we have dedicated directory only for ops operations, so that's why we have it here. So we don't need to install it globally. If I do SLS deploy, which means serverless deploy, SLS is a short term for serverless. It will start building on using from the beginning, because these architectures for production it takes too much resources, and there is a limit of 200 resources per stack from cloud formation. That's why we use this plugin to split them into smaller stacks, and they are deployed as a whole. While this is going through, I can now show you how it looks like in AWS directly. If I go to CloudFormation, already the first part of this project is deployed. It's only scripts deployment, so this will continue to the next. Okay.
But then for those that are curious, can you expand the .serverless folder?
Sure.
So just to show that there's no magic happening, what the serverless framework is doing is that it's creating these CloudFormation scripts, and then it's running them for you. So these are some of the standard things that it does. And then in addition to that, you'll see the custom resources that Shweta has created. But this is all, when you do serverless deploy, it's going to compile these, it's going to create them, and then it's going to deploy. And the first thing it does, which is why it worked so fast in the beginning, is because it runs the create stack, and the create stack just creates an empty stack. And then all the future deploys within the stack are just part of the update, and the update takes a lot longer. Create stack is blank, it's empty. Just it creates the S3 bucket.
Yep. I think I need to cancel this and try to redeploy because I had a connection breakup and this failed for some reason. Okay, so I'm gonna retry it. All right, so now we see I had a connection issue twice and it wasn't syncing. All right, so it completed the first stack, and now it's gonna start deploying all resources. What we are deploying right now, we are deploying some S3 buckets where application, React application will be deployed, and also some policies to give access the CloudFront to S3 bucket. And we are outputting some configuration. We are exporting, so we will be using across applications. If we are usually use a pattern name exports, and we can import the values everywhere we need. So for who do not know the services of AWS, S3 is a file storage. We will be hosting files here. IAM is for roles and permissions in AWS. Here we are building some. We have to create some roles which will be used during the deployments on code build, also in code pipeline, which are other AWS services, and also these roles are just how to explain, consider it as a user with limited privileges that have access only to do what we described in policies. So whatever we described here, this role would be able to execute only this. And we are not sharing any usernames and passwords. We are not creating users. We are creating roles and assigning to services, and then services can communicate with each other with IAM roles. DocumentDB is managed Mongo fork in AWS. Here we will be creating a cluster. Here with what we will be giving username and password will be that will be creating. Also, all of these are under VPC. VPC is a network inside your infrastructure. We created some subnets and security that is used across the whole infrastructure. Code build is from the name, it executes, it creates a machine and executes the code based on parameters that we give. We usually create a build spec inside our application. Do how to deploy this application in every step or some command on install before running the build, during the after the build is completed. These are all in the repository we open sourced, and it's pretty much ready to use. These environment variables in code builds are being set, so no need for no need to wait for deployments to be completed and copy and paste and move environment variables around our infrastructure. CloudFormation is doing it for us. Right now, as you see, now we had and then we use deployment. A new stack showed here, and it failed, and there is a reason behind it. Ops created a code pipeline here for deploying APIs, and right after creation, it executed it, but it failed because it needed some environment variables in CloudFormation that are not exported yet. If we go to the parameters, we see here there are any, and if we go to exports in CloudFormation, there are no exported values. These are being exported, but will not be published on. So we will try again deploying this one after our main stack is done completing. We can go on and see what other services are being deployed. For example, we can go to DocumentDB and see. All right, so it already created a cluster for us. It's available. Let's see if it created the instance. Instance is still creating. This takes usually 5 to 10 minutes. What else? If we go to code pipeline, I showed it was blank in the beginning. Pipelines are deployed from a stack. One succeeded. This means our app is already published. We can go to CloudFront and see the results. So here we see that a CloudFront is created with our name of the app, our stage, and let's see if we can access it. This domain is default for CloudFront. Because of this exercise, it was way easier to use the default one. We can always configure this one to use an alias of our custom domain. And this this is our React application. It contains only 2 pages, the welcome page and some small code guidelines, how we write code in React. Right, so let's see other resources. Okay, so this is finished. Stack update is finished, so all the resources are deployed. We can now go to code pipeline and retry deployment of stack that failed. It was this one. And if I do release change, it will to code build, which contains environment variables. It spin up instance and run the commands that we described in build stack here. We can now go and see the results. These are steps that code build follows. We first submit, and then this is queued in AWS infrastructure. It provision an instance where the code will be deployed, code will be built, and then it downloads the source from GitHub using our credentials that we provided in secrets. And then it will run the commands that we wrote. So if we follow the logs, this will also deploy some resources. This will deploy lambdas. I can show you where lambdas are being created. So first we ran into into ops folder, and we did SLS deploy manually from our computer. And now API is being deployed, but not from our computer. It's being deployed from code pipeline, and also the web is being deployed from code pipeline. There is no need anymore to do any action from our local. What is being deployed right now is these two. Yep.
Let me just interject because you were breaking up. Let me just make sure this came out clearly. So when the way Shpitim has organized the code is that in the ops folder we have the core infrastructure configurations and resource management. So you deploy that once from your local, and then as part of that, it's actually creating all the CI/CD infrastructure in the cloud, such that beyond the first execution, then everything is being executed automatically when you check something into source control. So this is a one-time step, and then every other step is fully managed by CI/CD in the code build.
So what is being deployed in API is a role for this Lambda that will be used for execution, during the execution, and also some API endpoints across operations, and we will be creating another one just for sake of demoing it, how easy it is to deploy after you get things set up. All right, so previously we saw this information in our computer. Now we see in code build, the stack is being deployed. We can go in CloudFormation list and see the status. And also I will are being held. Okay. So API right now is deploying functions, is deploying lambdas. These are taking more time because they are under some subnets and VPCs. Otherwise, they deploy way faster. Also, this will deploy API gateway. Exports can be found here under CloudFormation exports. For example, I've exported the endpoint for DocumentDB. Here is the cluster, plus security group, stuff like this that we need configure the application. Also, when this stack is finished, it will export. Okay, so it's complete. Also, this will export some. This time, it exported only the API gateway URL. Now, if we go to lambdas, previously we had only this one. Now we have delete blog, get blog, update blog, create blog, and fetch blog lambdas. We choose to deploy like this because it's easier to debug. when we have an issue. For example, we have logs. It's here. These can be merged into one. But it's more complicated to debug. We can test now. If we go to API Gateway, we will see our API here. It was created. Here are the endpoints, /blog and /blog ID with get and post methods, which fetch all blogs, create new blog, delete them. And here are stages. We deployed that. Here is the link of our API gateway. This was exported also in CloudFormation. All right, so try to go here and access /blog. We should see empty array. It is in plural. All right, so we have an empty array, which means it connected with DocumentDB, and right now it has no records on it. I'm gonna use this API to create some blogs, get them, and do CRUD operations. I'm going to use Insomnia as a REST client. This is an API that was deployed. It should turn into array as it was running in browser. Sorry for my bad internet connection. All right, so it has nothing. I can now go on and add a new blog. I'm gonna add only a test here. Okay, so it returned with 200. It created a new blog. Now, if we go back and fetch blogs, it will return an array of what we created. Right now, there are no validations, so we can put in database whatever you want. Hello. Let's create a new one. All right, so it created a new record. And now we can delete that one. Again, sorry for my internet. Okay, so it deleted. We fetch only one record. Okay, now I'm gonna show the magic that is happening behind the scenes. We will be focusing only on API this time. Let me close these. Okay, API gateway and lambdas are being configured from this function. Here are the name of resources, which requires a handler. A handler, we are using Express with serverless. So all our handlers, we would be using a new handler for every route. So we are using for routing and not directly API gateway. We are exposing, of course, HTTP to API gateway, but internal routing are being managed from our Express configuration. Here are just some metadata that tells CloudFormation how to create these resources. For example, fetch is with method get on this endpoint. Then we have a get method, which is under blocks, and it requires an ID. It is get. Also, it's possible to have validation in gateway level. Cores all configured. right now I've configured it as a true, so course is allowed. Here we allowed course. Here are also some important stuff that are deployed from our ops deployment. These are the exports that are previously exported from deploying for stack, and then here we are just using the services. Let's call it, for example, plans. We need to have that service in the same network with same security group. We could just import these. There's no need to pass one variables from one function to another. Also, this is important because we just created some records in database, and we created the Mongo connection without passing that information down to the application. In CloudFormation, we are using join and also import to construct the Mongo URI, and this is being used in application to for connecting into the data. We can easily now check the overview. If we run npm generate, it will ask us for a model name, which is entity name, basically. And I'm going to give it to article, for example. Right. And it generates routes for us, services, repository, requests, also these CRUD operations, and also it registers to the serverless. So if we check the changes with only one command, in the set of Express configuration, it imported the route and also it's registered in serverless API. Also, it added the file under functions. This is not affected. And also it created these bootstrap files that you can quickly use them. For simple code operations, you don't need to do anything. You just redeploy the stack. But we have already configured the continuous integration. So all I'm gonna do is commit these to my repository. So I'm gonna deploy these. Just also Husky is configured in this project. Also tests are being run. If you do push, it will run unit tests or integration tests, whatever you wrote. If you do only commit, it will run the lint. It is close to what we have in production, except some middlewares and validations. Now, I just pushed the code in the service configured to be watched, and we have just to deploy. So if we run the code pipeline, we should see activity. Okay, so here we see in progress both APIs and also UI. UI, we didn't do any change, but because they are both in the same repository, they are being triggered. You can always split into smaller repositories to avoid these. If we check now the API, it is going to the same process. It pulls build commands to fully deploy the code into the infrastructure. Previously, we had an API gateway. Let me go there quickly before it's deployed, so we see the changes. Here we had only 5 lambdas, 5 endpoints. We had log get, post, and also delete, get, and patch for specific object. Here, after the deployment, we should also see articles that we just generated after this is completed. Meanwhile, I'm gonna go and create a new page. Let's call it meetup. Okay, I'm gonna register this route. Actually, right. Also, let's have a link on that. I think it's enough. We will push this code as soon as we have, as soon as the API is deployed. Let's see if we have any change in API gateway. Yep. So right now we see article. Let's try something like we submit blocks. If we refill the blocks, it should return only one item that was left without being deleted. Now I'm gonna clone this URL. I'm gonna fetch, articles. So there are no articles. So this is the magic that is going on. We can even create a new article. I didn't write any line of code for providing these functionalities. So these are being all handled from, oh, come on. Okay, so it's created. Now, if we fetch articles, it will return 1. If we fetch the blocks, it will return 1. So pretty much we have everything for CRUD operations ready for production. Of course, we need to add validation and also authentication. That will not be covered in this session, but that is also part of AWS API gateway. Under authorizers, we can have a new authorizer, which can be. All right, so let's deploy also the React. I'm going to go to CloudFront. Just for sake of seeing differences. Right now we are in this CloudFront distribution. Okay, so this is the old one, the code that is already in Git. Now I will be pushing the new code. Let's see if I did any mistake here. I imported. Okay, code is in GitHub. We can go in pipeline and see. Last time they were executed were 3 minutes and 4 minutes ago. Anytime soon they should start again because we pushed the code. Okay, so my last comment was meetup page. It took it, and CI/CD is running. Right now we expect changes only in UI, so we can see what's going on here. How it's configured. The first step is to pull the code from GitHub and then pass it to code build for building it. And then the build under this folder is transferred to the S3 pointed bucket for serving it through. You can see progress of building. Oh, it's already completed. All right, so it ran npm run build. It started the build, and then it passed to the next step, which was uploading to the S3. We can even go to the S3 bucket and see the results. All right, so this is the one. This is the compiled version of our React app, which is being front do caching. So if we go directly here, we may not see the changes usually. We see, but all right, so we don't see changes immediately. We created a new URL here, but CloudFront does caching, so we need to manually invalidate this. This can be also automated. It can we can add a new step in pipeline. We can add a new step in pipeline. I'm gonna just show it how these steps are configured, but we will also add this in the cache validation after code is transferred to S3, and then we can create here an action, the cache, which can be Lambda. Function name, I already have the Lambda for invalidating CloudFront. This is not provided from AWS built-in. You need to write a script to do invalidation. Hope in the next releases of AWS services they will include this. For now, we can just trigger a new Lambda that does the this succeeded and failed. For example, the continuity will. Right. So let's see if the invalidation is completed. And here we are supposed to see a new link here. go to meetup, which send us to the new page that we just created. So pretty much this is from now on all automated. If you do changes in UI and you push it to a branch that you configured in secrets to be watched, every time there are changes in Git, it will trigger pipeline and do the deployment for you. If you change endpoints, if you delete, if you create new ones, or you just change some code logic with changing the infrastructure, anytime you have changes in Git, the whole process will continue following you up. If you have any question, please shoot.
Hey, Shpetim, Darko here. I have a question here.
Sure. I
saw this is a great example how to deploy a properly architected serverless application. So actually, the application code is there like, or have you done it that you deploy also the infrastructure through a pipeline, or is the infrastructure are the infrastructure updates deployed solely through the command line, like from your workstation?
Yeah, in ops, we have the infrastructure code that we can deploy manually from our computer, or
Okay.
it can be built in code build directly.
Okay. And you think it would be better for us to create a pipeline for this as well, right?
It really depends. Usually we keep infrastructure in complete different repository, not where the code stands.
Okay.
So
let me interject. So, Darko, good question, by the way. There's depending on the type of solution, we've taken different approaches. This boilerplate solution is more for a centrally managed resource architecture, where you have a VPC and a bunch of resources that you're okay sharing across maybe multiple APIs. We have different architectures that are more microservice driven. And in the world of microservice, we put a lot of effort to make sure that everything is completely vertically independent. And in such cases, we have everything completely managed within every single API. Some of the challenges that we faced there, which is why we didn't address in this demo, is that we sometimes have a difficult chicken or egg problem where we need maybe an IAM role to exist to add authentication, but then that IAM role we want to create from there. And so avoiding those kinds of challenges for this kind of demonstration, we went this route. But that's what we do in a microservice oriented individual API type solution.
Got it. Okay, cool. No, I'm just wondering, serverless being, infrastructure is part of the serverless application. So I'm just wondering, but yeah, fair point. Thank you. Thank you also, Shpetim, for the excellent presentation.
We have plenty of time for questions, but again, I do apologize for connection challenges that we had. And I know probably everyone followed the video, thankfully, was fine, but the audio was breaking up. So maybe I can do a recap just to make sure that everyone was able to follow. Shpetim, if you let me share the screen and then correct me if I misstate something. But I just want to do a very quick summary of everything that you covered just by looking at the code on GitHub. Okay, so again, this is open source. It's a boilerplate application that you can clone now and fork or just make a copy of. The code is structured in three main folders. You've got the API, ops, and web. The idea of ops, as we were discussing with Darko just now, is that you have shared infrastructure that you put in here, and this is for example the CI/CD, because obviously you need something to be configured in the cloud first before you can start doing continuous integration and deployments. So what we've defined here is we've got This is also a serverless project, but for those of you that may be newer to serverless, a typical serverless file gets configured in such a way: you define a service name, you install plugins. The community has many plugins available to do different things. This is where you define the provider, meaning where your code's going to run. Here we're defining a node, latest node type provider, specifying a dynamic region based on an environment variable. You can define stages, and then a role. The role specifies what IAM role the Lambda functions will be executed under. So if you define the role here, all of your functions defined in the serverless file will assume this role. You can also define it at the function level. So if you can have different roles for different functions. And then custom is just custom variables that you want to define so you can use them everywhere in the file. The resources section that you have down here, everything below this line is pure CloudFormation. So when Shwetam was showing his demo, I asked him to expand the .serverless folder, and we saw that serverless had created a couple of scripts, which were CloudFormation scripts. Anything that you add here is just going to inject in there, because serverless framework by itself is using CloudFormation. So then anything else that you add here will just be embedded. And then the nice thing is that these, you can communicate, you can reference things from here into the section, like for example the custom configuration. And then a typical way that we configure our serverless files is that we have a resources folder here where we break down every category of resources into its own file for easier management. So for example, CloudFront is here, and this is purely CloudFormation, even though it's being consumed by the serverless framework. So if you ran the demo before or you're running it now, essentially you need to run this to build the basic infrastructure on AWS, such as CI/CD roles and some of the basic reusable resources. Then if we go into the web is the easier part, so I'll cover this first. So this is a basic React application with some standard structure, component folder, pages folder, some utilities, some constants where we typically define a configuration file, where we consume environment variables that are defined during the CI/CD process or local development process. And then nothing special here. We didn't focus on React, and the point of these meetups is not necessarily React. And then if we switch back to the API, this is where the business logic of the application resides. And anything, we can always go in here and add more resources that are specific to this API, or we can leave them in a general folder. So Darko, to your previous question, we do have, for example, a specific Lambda role here that we've defined specifically for this API, but the rest are being consumed dynamically. Again, more plugins up here. You can see we're using Webpack, which makes the development easier. We're using serverless offline, which allows for easy local development and Lambda environment simulation, and then some other helper plugins. The provider is again nodes and a bunch of other configurations that you can look up once you review the file. Shwetam mentioned that we are proposing here rather than have passwords in configuration files or any other insecure location, Shwetam has generated the URI of the document DB source here dynamically, and it is generating the connection string dynamically by referencing other resources, including the secret coming from the secret store. This is definitely more secure than something like using configuration files. In future sessions, we're going to talk about even more secure ways, because this is still an environment variable. So if you have access to this Lambda, you can still see the password, which it's one level up, but we can take it higher by by accessing the either accessing the secrets at runtime or by giving the Lambda role permissions to access resources without needing a password. We talked about cores, and again, these are all custom variables that we define here, but then we reuse them elsewhere when we need them. And typically, even the functions themselves, we break them apart this way because, again, it just makes organization much easier. So if we go into the function folder, these are all the different functions, each one of them resulting in a Lambda function itself. Couple of things to notice here. Shweta mentioned that we have a VPC configured as part of the ops folder, and we're considering that to be a centrally managed resource. The reason why we're adding a VPC is because we're using a document DB, and we're trying to make it more secure. If we were just using Dynamo, for example, we would typically not do a VPC because those are inherently secure, and the security to those resources can be easily managed by an IAM role. This is where we're defining the cores attributes for each one of these methods. This is a simple CRUD operation. What else is interesting here that we covered? I think one of the very fancy things that was covered is the use of plop, these generators. These are templates that get created that allow for easy or rapid, let's call it rapid development. So you saw that Shweta was able to add all the necessary code, boilerplate code, for a new resource that he added called article in the previous demo by simply answering a question. And then the automation generated everything else. So it generated the repository service route. It even injected itself into the serverless file to make everything convenient for you. So if you remember from the demo, all he did was run that command and then check it into Git and push it, and then he was able to run a CRUD operation on AWS.
And Visar, that generation is part of this framework, or that's
no,
something?
It's another tool called Plop.
Plop. Okay.
Yeah, and this is it's using for those of you that may be familiar, it's using handlebar syntax.
Yeah.
And then you just define these templates, and then I'm assuming it's here, right? Plop. Yeah. So it's down here. It's just every dependency that you add. Nothing to install. Another thing that we typically do that you may have noticed, but I don't know if you're familiar with this use of Husky to do pre-commit operations to add additional quality controls before anything makes it into Git. You can obviously run quality controls in the CI/CD process, but this shortcuts the process, and it prevents you from committing anything to begin with and not waste the time it would take the CI/CD process to cache them. I think I covered everything in a very, very accelerated way, right, Shweta? Did I miss anything? Just a recap.
Thank you, Visar. And sorry again for my bad internet connection.
Okay, so now we can open the conversation to questions, comments.
Thank you so much, Patim. It was very, very useful presentation. Keep doing this. Yeah, I have only one question about the Git flow that you are using, guys. So we are struggling basically with pull requests in our company. Do you have any strategy on how you trigger the pipelines in general? So what kind of services you use during the PR?
Can you elaborate more on the type of issues you're having? Maybe we can fine tune the response.
Yeah, sure. I mean, before merging the pull request to specific branch, sometimes developers need the feedback immediately in the pipeline. They want to trigger pipeline before going to develop or to other branches as well. Do you have any strategy on how you do that?
So personally, and I'll let Shvitim respond also, but my opinion is that CI/CD is a better approach, and a CI/CD requires a single branch strategy, not a pull request driven strategy. If you can afford to build a trustworthy CI/CD pipeline where you know that you have enough quality controls in place to where your code is safe to have that continuously integrated, that is the most efficient strategy, and that's what continuous integration is all about, right? The code is continuously being integrated, and you don't wait for someone to work for a few days or a week or a couple of weeks on a branch and then do a merge, because those changes are larger, and then you have to do more diligence and merging and a lot of things that CI/CD was designed to fix. So that's my opinion, and I know there's many in the industry that share this opinion of a centrally managed branch. So basically, we typically have a develop branch and a master branch, and master just represents production. In some cases, we also have an intermediary UAT type branch, and the only reason we have those is just to control kind of that release process, but daily development happens on the develop branch. Everyone uses develop branch directly. Darko, do you have an opinion on that?
So yeah, in this case, especially when this is a single branch driven CI/CD, pull requests kind of go outside of the CI/CD pipeline in itself, and that's been a discussion a lot when it comes to people talking about, hey, how to properly handle pull requests. In my opinion, and this is kind of my opinion, and as well as something I've seen before, is in this kind of a situation, you only handle staging and production in this pipeline. All the development pipelines, all the things that the developer is trying to see if is it working, is done in development environments. So those development environments can be a specific development environment for that given branch, or for whatever arbitrary branch they use. And then once you decide to move into production, or somebody gives you the go ahead that your development tests are okay, we can push it onto the basically mainline branch, and it goes through staging, and if successful, it goes to production. That's kind of an approach we see, which in essence gives the developers freedom to play around with things without having to be too burdened with pull requests for everything they wish to test. So having a development environment per developer is good.
Yeah, so I think just to elaborate the way I understood it, my recommendation was to have a single branch for the entire team. I think your recommendation is to have a single environment for each team member.
Yeah. Okay, fair point. But when you say single branch for a team, I usually think of, you have your mainline branch, the thing that takes your code into production, and not every developer will test what they're doing on that branch, right? I'm not sure. Of course, there's like mono repo ways of development, but if you are doing like branch based, what we see is we have this single branch for the production and staging, and then everybody else has their own things. Just, hey, if I'm a developer and I wish to implement a feature by myself, or just playing around with something, committing to to the mainline branch could be problematic. That's something I've seen. But again, experience is different, size of teams, type of a project. Yeah, so there's a whole lot of things there.
Yeah, I guess it always depends. And it depends on all these other criteria.
The universal answer.
Yeah, if you trust if you trust your continuous development model, and you have quality controls in place, then my recommendation is always to use a single branch strategy. The highest benefit of doing that is that your code, I mean, that's what continuous integration means, right? Your code is continuously being integrated across different team members. And the benefit, aside from the fact that you don't have large merge activities at different points in time, you also have collaboration, because if someone is doing something wrong, the other developer will see it right away, right? Because they're continuously integrating each other's code.
Yep.
And they help each other maintain that quality. If you're doing it in chunks, this is the challenge I have when someone asks me to do a pull request review. I'm going to review the code, but I'm not reviewing the functionality. It may have been broken. There's no way for me to do a static code analysis on a pull request and say, yep, this is great, I approve. The code might look great. It meets all the coding standards, and it looks like logically it makes sense. But then you run it together and it all breaks. When you do CI, then that's the type of thing that you catch quickly.
I think it makes sense on small teams. On larger teams, I think it's required to go through pull requests. Otherwise, I believe one single branch for CI/CD up to 10 developers is good to go.
That's why agile teams are small.
Yep.
In Amazon, we use like a branch-driven thing. So, and there's only one main branch, and somebody has to look at your code first before you can commit to that at all. So, yeah.
I believe probably for a small project, this probably makes sense, but in the bigger enterprise solution, it's a bit different, let's say, and it's quite challenge to use only one branch for one pipeline, because there's a lot of dependencies and a lot of things that should go on.
Yeah, Zamira, what you can do easily is to create a hook if you are using GitHub to listen for pull requests and spawn a new environment only for that pull request. Of course, you need to create a pipeline for it, but you have flexibility of doing that in AWS.
Yeah, so I mean, we had some solution already. We are using not this one. We are using Lambda function because we have code commit as a source repository and not GitHub. So we have the full cloud native solution in AWS, but it's going to be very expensive because we have like 2,000 developers in the same time that they are creating pull requests, and they want before deploy this application, they want to test it. All the features, and this Lambda function continuously is going to trigger all the time that they create the pull request, the pipeline, but it's really expensive, and we are struggling to find a good solution to be cheaper and effective in the same time.
I don't have visibility. Obviously, I don't know the complexities of that environment, but again, the agile team concept is designed to be agile, to be fast and agile, and the more things you put in place to kind of break that velocity apart, the more governance you have to have in place. When we talk about larger organizations, agile obviously by itself doesn't scale, but there are scaling frameworks for agile, like the SAFe framework that was designed with this in mind. So you kind of, if you think about, instead of having 20 people on a team, you break it apart into smaller teams, and then you kind of at each layer, when you combine, you treat each team as an individual of a higher level team, and then as you keep abstracting that way, your process also follows along. So a single team is doing pure CI/CD, and then at the higher level, then you're doing periodic CI/CD. And then at the higher level, you're doing even fewer iterations of that periodic CI/CD. But there's no magic formula. Every organization is different. Any other questions? were folks able to follow along? Did anyone was anyone able to follow the code, download the code, and follow the steps?
Hey, Visar.
Hey.
Quick question, Alton here.
Anthony.
I saw you were presenting the, I think it was called Husky, if I'm not mistaken. It's a bit out of topic, but I was just wondering, what have you found easier to use in Husky other than, or maybe just a simple comparison between Husky and simple GitHub hooks. Why do you use Husky and not GitHub hooks?
Shpatim is the expert in this space,
Yeah.
but the GitHub hooks are running on the server, right?
Locally, they do run locally as well.
Also,
Isn't it
also
using those,
Husky uses, yeah, it uses it. But it's way easier to configure. For example, you can configure with Husky lint checking and only check files that are modified and not the whole project. So it works way faster than scanning the whole project. In the background, it uses GitHub hooks.
I got confused because you're saying GitHub hooks, but you mean GitHooks, sorry.
Yeah, Git hooks. Sorry. So it utilizes Git hooks in the background, but there's no Git hooks files as far as I saw, or probably I didn't look good enough in there.
Yeah, that's
I was
the
trying
magic
to
of
find the
Husky.
config files of the Husky setup. Maybe you could, I don't know if you could share the screen for a minute or two just to point me to the right direction, but I was curious to figure how this thing works.
That's the magic of Husky. There is no such configuration. You just install it.
Oh, okay.
But when you do install it, it's going to require Git to be installed. So it is talking to Git as soon as you install it. It's been a challenge to use it within Docker, for example. Typically, we don't install Git inside Docker.
Yeah, that's right. Okay, thanks.
All right, so do we have any other questions?
How about where would the community like to see this demo going in future parts? What would you like to see done in the future sessions? What areas?
Hey, hello.
Adrian?
So thank you for a great presentation you guys did for this. I mean, I'm not an expert in Node.js. I mean, we are more Python guys, but I love what you guys are doing here. But what I would like to see the next one on this case is, as I'm getting more familiar with this, to see how you're going to be able to implement the AWS Cognitive Authentication authorization using APIs.
Okay, sounds good. That's definitely something that is fairly trivial when you use the tools that we're using. So, but definitely good to know.
Also, there is one other thing I think Visar explained it before for the config.js, where you're passing the environment variable for document_db _ URI. So why you guys don't take advantage of AWS SDK to call the AWS secrets here? So you don't pass or you don't expose the username and passwords and environment within the Lambda.
It adds delay on execution.
Yeah, there's different strategies. It does add some delay during warm-up time. You can cache it.
Yeah, you can cache it.
But the warm-up time sometimes is important. There's always ways to optimize, and there's always ways to work around. My preferred strategy is to not have to use it. And the direction Amazon is going is that it's trying to make it possible to access more and more resources without needing credentials directly. For those of you, for example, that are using RDS, you might know that AWS has recently released an API-driven access to RDS to avoid having to pass credentials on. And then there's other strategies that are possible with, integrated password access, where the password is completely managed by secret manager and the passwords are rotated over time completely dynamically. So I think AWS is moving in that direction. The reason why these things still exist is because Amazon is very good about integrating existing products into their platform, and those existing products are reliant on credentials. So until they get there, we just always have to apply the right strategy to the right problem. But at the very least, what we showed in this demo is that we avoided having passwords as part of the source code or CI/CD process. During runtime, yes, the password got embedded into an environment variable that does pose its own risks, but the trade-off is like we said, we're dealing with a performance challenge.
And maybe one more, sorry for just jumping in here, but one more reason I've seen people use Secrets Manager instead of environment variables, despite the fact that it introduces that latency, which can be avoided at some cost with caching until the app restarts, at least, is that so people use it for the flexibility of changing config values, or let's say secrets, passwords on the fly while the app is still running. So they utilize the power of the Secrets Manager to have a UI that you can change passwords on the fly while the app is running. Instead of writing let's say an admin dashboard to manage all the configurations.
Yeah, all fair points and valid. I've seen demos. I actually haven't done it myself. Darko, maybe you've probably seen more demos and have done it. But the fancy demo that I have seen is using it for RDS, where it's not just centralizing it using Secret Manager, it's also rotating it on a periodic basis, and everything just working transparently.
So let me add a thing here. Think of Secrets Manager as the tool, the magic tool that gives IAM permissions to everything, right? So you don't have to care about a password. You can have it automatically change, for example, an RDS database password, or it can change anything. It can run a Lambda function to rotate a password. So in essence, without even giving your application a password at any point, you can enable any service out there, even a service running in your own data center, to be basically IAM compliant. The only thing you need to do is give your application IAM permissions to read the password from Secrets Manager.
That's right. Unfortunately, it's still not integratable with all the services, but the fact that they provided triggering a Lambda function is a lot helpful. A lot helpful because you can then through Lambda functions just tackle every other resource that Security Manager doesn't support directly.
Exactly, and Lambda function is the glue that powers everything. If it doesn't work, you can glue on a Lambda function to it, and it'll probably work. So
that's funny.
Yeah,
but it works.
Exactly.
Any other question? Great conversation, by the way.
I like how Shpetim glued together the step to clean the cache for CloudFront with the Lambda function. Which, by the way, I think he should share that script on the repository. Somebody might find it useful.
Yeah, cache invalidation is very important when it comes to CloudFront, because sometimes you deploy a change and you're just like, oh, it doesn't work, but yeah, cache.
I think we can we add that to the build spec too, because the CLI is available there.
Yep, we will do it and update the repo.
Any other questions, comments? Okay, all right. Well, it looks like this is it. Ismail, did you have any closing remarks?
Yes, so don't forget, to follow Polymath Labs GitHub account, because we're going to update this project in the coming days. Maybe we are going to have another meeting when we explain some other features that we're going to add to this Bootstrap project. And again, thanks everyone for participating, and thank you for being patient, and see you in the next organization meeting.
Thank you, everyone.